The electrolyte of an automobile lead storage battery is a 3.75 sulfuric acid solution in water. It has a density of 1.23 grams per milliliter. Calculate for the sulfuric acid the mass percent, the molality, and the mole fraction. So the mass percent is given by mass of H2SO4 divided by the mass of the solution. Times 100. For this problem, we'll assume that we have 1 liter of solution. So in order to calculate the mass of the solution, we'll times 1000 ml, or 1 liter, times the density, which is 1.23 grams per milliliter, to give us a value of 1230 grams of the solution. So because we're given the concentration of sulfuric acid and the volume of the solution, we can use that in order to calculate the number of moles provided by the sulfuric acid. So the moles of H2SO4 is equal to the volume So the moles of H2SO4 is equal to the concentration times the volume. So 3.75 molars times 1 liter gives us 3.75 moles of sulfuric acid. And in order to determine the mass of sulfuric acid, we'll take the number of moles and times it by the molar mass. Which is equal to 3.75 moles times 98.078 grams per mole, where the moles will cancel out, leaving the grams, which is equal to 368 grams of H2SO4. So now we need to find the mass of water within the overall solution. So we know from the beginning of the problem we calculated the overall mass of the solution, which was 1230 grams of solution. And we'll just minus the mass of the sulfuric acid, which is 368, in order to determine the mass of water. So that comes up to 862 grams. So to calculate the mass percent of H2SO4, we'll take the mass of H2SO4, which was 368 grams, and we'll divide it by the overall mass of the solution, which was 1230 grams. And we'll times that by 100. And that will give us 29.9%. So now we need to calculate the molality, which is equal to the moles of solute divided by the kilogram of solvent. So from the earlier problem where we calculated the mass percent, we were able to also calculate the moles of solute, which was equal to 3.75 moles of H2SO4. But now we need to convert the mass of water, which we calculated in the earlier step, and convert that to kilograms from grams. So the mass of water was equal to 862 grams. So 862 grams times 1 kilogram divided by 1,000 grams is equal to 0.862 kilograms, where the grams will cancel out. So now we'll take that value and plug it into this equation. 0.862 kilograms. And that is equal to 4.35 molal. So now we want to calculate the mole fraction of H2SO4. So a mole fraction is equal to the moles of solute divided by the moles of solute plus the moles of solvent, where the solute is H2SO4 and the solvent is H2O, or water. So the mole fraction of H2SO4 will be equal to 3.75 moles, which we calculated earlier. But now we need to calculate the moles of solvent. So we know that the mass of water is 862 grams. And we know that the molar mass, which we can calculate by using the periodic table, is equal to 18.02 grams per mole. So by using this technique, where the mass divided by the molar mass is equal to the number of moles. So the moles of water is equal to the mass, which is 862 grams, divided by the molar mass, which is 18.02 grams per mole, where the grams will cancel out to give us a value of 47.90 moles. So we'll just take that value and substitute it into this equation, where the moles of solute is 3.75 plus the moles of solvent, which is 47.90, which is equal to 0.0727. And if the question were to ask you what was the mole fraction of water, You can easily find it by subtracting 1 from the value that you calculated earlier of H2SO4. So 0.0727, and that will give you a value of 0.9273. So you must always remember that the mole fraction will always add to a value of 1. And there, we solved the problem.